Okay, so now we're doing a whole logic question. We've got some piece of code, we need to prove some property, that's great. In the questions below in your answer may refer to the loop code as loop. Okay, so this is the loop code, all of this stuff here. The body of the loop, so just this part here as body. And the initialization assignments as init. And the whole thing is called half. Okay. Given the desired post condition x equals 2 times y, what is a suitable invariant for the loop? Okay. So each time the loop is ran, x gets twice as big. Sorry, x gets 2 bigger and y gets 1 bigger. And they both start off as 0. So if we just run the code for a bit, so let me just like sketch a table in the margin. So x is 0, and we run the code once. X is 2, y is 1, run the code again. 4, 2, run the code again. 6, 3, etc. And looks like x equals 2y is going to be a suitable loop invariant. Suitable invariant, okay. P is equivalent to x times 2y. Whoops. X is equal to 2 times y. Is it asking for justification? Nope. Okay, well, that's my answer, and that'd be a perfectly valid answer. Cool, let's move on. Prove that your answer to the previous question is indeed a loop invariant. That is, if we call your invariant P, show that P body P is a valid Hoare triple. Okay, cool. So we want to prove, and I write my goal at the bottom, x is equal to 2y, the code body, so x is assigned to be x plus 2, y is assigned to be y plus 1, and then P again, x equals 2y. So we want to prove this, so let's get our rules at the ready. Here we go. So we're probably going to have to do sequencing backwards. So I've got x equals 2y, I've got the first bit of code, and then something, and then I've got that same something. Y is assigned to be y plus 1, and post condition x equals 2y. Alright, doing assignment rule backwards, what's going to be here, such that when we replace y plus 1 with y, we get this over here. Looks like x equals 2, y plus 1 to do the trick. Replace y plus 1 with y. Yep, that works. So this is valid by assignment. That means the same post condition as this precondition. These two things are going to match. Otherwise you can't do assignment. Can't do sequencing, I beg your pardon. So from here to here, is this immediately true by the assignment rule? Doesn't look like it. So what we can do is we can move the post condition up and then do assignment rule backwards, and then hopefully we can do precondition equivalence or strengthening to get what we want. So if I do assignment backwards, I'm going to have an x plus 2 equals 2 times y plus 1. That's true by assignment. And then it's not hard to see these two statements here are equivalent. If x plus 2 equals 2 times y plus 1, that's logically equivalent to x equals 2y by logic. And then we can get here by precondition equivalence. So line numbers 1, 2, 3, 4, 5. Assignment logic precondition equivalence. Which order do we cite them in? We cite the logic rule and then the previous lines, so we cite it 2, 1. Assignment, and then sequencing. In which order do we cite them? The first thing, then the second thing. So cite this rule here, sequencing by 3 and by 4. Cool, there we go.